enjoy your friends some more, rest, maybe eat a cheeseburger and have a milkshake. That was about the only thing I wanted y'all doing over break. Yes, I did that.
I just wanted to make a point that on Saturday night I slept for 14 hours.
Makes you normal, kid. That is good stuff.
Teenagers need the most sleep out of
Makes
What
you-
cares? Good.
All right.
whatever.
Let's go. You guys have these on your pages. Let's kind of review some absolute values. So if you remember, an absolute value is the distance away from something. And so you can never have a distance that is negative. So let's take a look at the first one. And a lot of times students will say, well, let's make it just a t-table. And the best way to make a t-table is just pick some values around the origin. So -2, -1, 0, 1, and 2. Those are always good starting points. I mean, some students want to come on, I'm going to pick 8 and then 71 and 3. And you're like, why? No, just kind of try and pick things where you'd be symmetric. If you plug these in, you're going to find you get 2, 1, 0, 1, and 2. And so if you plot these, this is what they look like. And that is our most basic absolute value graph. Meaning there's nothing else I could do to it that's going to make it any less than that. What about on that second one? I have a negative there. What do you think that does to everything? Yeah.
Well, it's a negative x, so it doesn't count.
Well, what basically happens if I plug any of those numbers in, these all come out to be negative. I can't have a -0 because 0 is not positive or negative, right? So that's what this does. And so if you do this graph looks like this. And I think most of you would feel pretty darn comfortable to say, well, having a negative out in front of the absolute value sign makes the whole thing flip upside down. Is that okay? Any part of any of that you're like, dude, where is this all coming from? So there's one thing I want to talk about on these, and it's this point here and this point here. And we're going to call that the turning point. So the turning point, where it goes from going up to going down, or where it goes from going down to going up. That verbiage okay?
Yeah.
Anything about that you're like, turning point, what does that mean? Good? Cool. All right, so the turning point is what we want to kind of focus on. So both of these have a turning point happening at the 0, 0. Agree? A lot of times, if we can say, where is that turning point going to move to, we can go about graphing this pretty quickly. So I think there's a second set of right here. All right, so that's supposed to be a y. Sorry about that. So y equals absolute value of x. And then outside of that, we have +3. So anyone want to take a shot at this? First off, do you think this would open up or down? Well, up. Agreed? Does everyone feel a little good about that, opening up? And do you think the turning point that had been 0, 0 is going to move? And if so, where's it going to move? Just guess. Let's see. What do you think? Move to the left. Okay. So, if you think it's going to move to the left, let's build upon that. If it moves to the left, that means it would move to the left 3. So then, on a t-table, let's pick -4, -3, -2. Just to build with your conjecture. And thank you for submitting out there. So if I just plug this in, I get absolute value of -4 is 4. 4 plus 3 is 7. Absolute value of -3 is 3. 3 plus 3 is 6. Absolute value of -2 is 2. 2 plus 3 is 5. So then I get -4 and up 7. 1, 2, 3, 4, 5, 6, 7. -3, 6. -2, 5. I don't see a turning point quite yet, though those points do indeed exist on this graph. So it doesn't shift left to show a turning point. What are some other things that might happen here? I mean, should we keep plugging in points, see if we can get something out of it? I plug -1 in, absolute value of -1 is 1. That's going to be 4. Plug 0 in, that's 3. Plug 1 in, that's 4. What did I just find?
Turning point.
Found turning point. So, if I added 3, use your verbiage for me. If I added 3, what does it appear that the turning point did? Did it move?
It
Goes up. How many? 3. You count.
1 x 2 s.
Yep. So, this seems to have moved the turning point, we'll call TP, up 3. Does that language make sense? Okay, what about the second one? If I added a 3, it moved it up 3. What if I added a 4? What do you think it's going to do?
Up 4.
Move it up 4. What's the negative out front going to do?
Make everything.
Do what?
It's gonna flip.
Flip it, okay? So I'm going to go up 4. 1, 2, 3, 4. There's my turning point. And it's not going to go up, it's going to go down. So use your verbiage to say how does this look different than the parent function? And I'll just draw the parent function up there right now. The parent function is going to look like this. So what's the difference between the pink and the green other than the color? I have to say that. I've only talked long enough. Different colors. Okay. It's dotted. Okay. Yeah.
They have different turning points.
They have different turning points because the turning point had shifted up 4 in this case. And then what else did it do? Yeah.
There's also going into the negatives.
So it went the opposite direction. Does that also make sense? So the turning point is up 4, and then the whole thing flips over. Does that seem to make sense? Is that language that we might be able to use? Can I move on and explore? So if we added or subtracted outside of the absolute value, that shifted it up or down. If we have a negative outside of the absolute value, that means it's going to open downward versus upward. Let's see what else we can do. What's different about this one? What can we see with the absolute value? Is the adding of 3 inside the absolute value or outside of it? It's inside. Outside of it meant it moved up 3, right? But this is inside of it. So I think Oliver had touched upon this right here. Okay? If it's inside, it will move left or right. And it's always opposite what you think when it's grouped. Opposite of what you think when it's grouped. So just by looking at it, what your first notion is to say, hey, it's going to move either right or left. But this one, if I, by that term, opposite of what you would think when grouped, which way is this going to shift? I think most of you would say, I'm adding 3, so it should go right. But anytime something is grouped in math, it goes opposite of what you would think. So it's going to shift left. Okay, and that's the turning point. It's still going to do this. And let's just in yellow have our parent function. So the yellow was our parent function. Give me your verbiage of what the blue function is doing with respect to it. They're both open in the same direction, up. What else can you tell me from the yellow to the blue? Yeah.
Different TPs, like different points.
Turning point went where?
on 3.
So the turning point went to -3, 0, which is that. Is that okay? So it went from 0, 0 to -3, 0. So if it's grouped, it's going to go the opposite direction you would think. So look at the one that is y equals negative. The negative out front is going to do what to the absolute value? Is it still going to open up? Or is it open down?
Open down.
Open down. Okay, so this is going to go down. And that's x minus 2. Which way is this going to shift? Huh? Right, how many? Right 2. Okay, so my turning point is going to go right here. And it's going to open down. Again, let's just do in yellow. This is my parent function. So what do you feel? What would your words be to say, I'm going from the yellow to the purple? What kind of terminology would you like to use? Can I say flips upside down?
Yeah.
Is anyone like, why I don't see it flipping? Can I say shift right? That all seem okay? So when it's grouped inside the absolute value, it shifts it left or right, and it's opposite of what you would think, because it's just how the math is going to work. If you add or subtract outside of the absolute value, it moves it up or down. If you have a negative outside the absolute value, it flips it upside down. So it changes all your y values to be opposite value if they work. May I move on? Do I need to be making a t-table on all these? I don't think so. Okay. I have a 2 out front in this one. So I'm going to graph this one first. That's the parent function. Is that okay? What do you think that 2 out front is going to do? Is it going to make it skinnier, fatter, shift it left, right, flip it upside down? Is there any of those things up there? Is this different than we've seen?
Yeah.
It is. So what I would do is this actually makes it grow twice as fast. It's still the same turning point, but it's going to go, it's growing at a rate twice as fast. Rather than right 1 up 1, left 1 up 1, it's going to go right 1 up 2, left 1 up 2. Give me your verbiage of what you think that green graph looks in reference to the yellow. Yeah.
It's more steeper than the yellow.
More steep, I like it. Do you agree with that term?
Yes.
I like the more steep. Let's use it. Only like the big mathematicians out there, they want to make it more complex than that. But I think if we make it on a elementary vocabulary, I think that's awesome because I understand more steep. Okay, would it be more fun to slide down the yellow slide or the green slide? You go faster on the green slide, right? Then you got the kid who never once took a chance. They're like, oh, I'd never go down that slide. I don't. I'm sorry.
Yeah.
I might.
I was that kid too.
I was that kid that would make fun of those kids.
Me
I
too.
would've beat you.
You want to hear? Oh, this is bad. I can tell you this because the statute of limitations ran out. We used to have outside playgrounds at McDonald's rather than these ball pits.
I hate-
Festering.
I know you're
Festering
talking
pools
about
of piss and poop.
Go with that.
Like there's pit
So-
balls filled.
But we used to have. They were all outside, and so at McDonald's, they used to have this slide, and they put a chain across the slide when it was too hot outside, meaning the reflective slide was facing the sun. So it was basically a stove. So I remember one time, you only go down a slide once in the middle of the day in Arizona. And then you realize we'll wait till the early morning or late at night. But I remember I took the chain off, and walked away.
Oh, no.
All of a sudden you hear sheer pain. Kid's basically stuck to it. Their legs are adhered to the slide. It's like, who took the chain off? Well, I don't know. My French fries. That was bad.
Bad, you're bad.
You tell me you wouldn't laugh at that.
I would laugh.
I didn't understand the
Huh.
whole story.
You got third-degree burns?
Yeah, I
You're
was like-
stupid.
I was dazed.
All right. No, no more stories. You guys, you get one story a day. If you don't understand it, sorry.
I didn't really.
All right, so this is my parent function, the most basic. What do you think is going to happen when I have a -3 out front? It's going to go down. And what? And it's going to flip. It's going to go down. And it's going to be skinny or fat?
Skinny.
So can you say that on this one, from the yellow to the green, it was the green skinnier? Is that okay to say that? So I think this one, the green's going to be skinnier as well. Or let's just do it in red now. So I'll do this one in red. So it's the same starting point. It's going to go right one down 3. Left one down 3. Right one down 3 more. Left one down 3 more. So that looks even to be more steep than the green one would have been, even though the green one's open upward. Agree? It's skinnier. It's growing faster in the vertical direction. So put something like this, even more steep. Is that language we can be okay with? Okay, so let's see. We've added something to the outside, and that shifts it up or down. We've combined something inside of the absolute value, which shifts it left or right, and it goes opposite of what you think. We've done a negative out front, which makes it go upside down. We've done a number out front, which makes it skinnier or fatter. All right, let's see if we can combine a few things. All right, so I'm going to draw my parent function in here. This is the most basic absolute value. Okay? So, let's take that 3 out front. What should that 3 out front do? Make it steeper, make it fatter, shift it right, left, up, down.
Should make it
Fatter.
Steeper. Okay, so steeper. Is that okay? What should this added to do to our turning point? Shift it left, right, up, down. Flip it upside down.
Left.
Left, 2. Good. And then what should this -1 do? Up, down, left, right, fat, skinny, flip it upside down.
Flip it upside down.
Down. Down what? 1. Down 1. If it was a -3, I'd flip it upside down. So move down 1. All right, so let's go left 2, 1, 2, down 1, right here. And then I'm going to go right 1 up, 1, 2, 3. Left 1 up, 1, 2, 3. Right 1 up, 1, 2, 3. Left 1 up, 1, 2, 3. Okay, so using your verbiage from the yellow to the purple, give me one fact that you feel pretty confident saying from the yellow to the purple. One fact. Shout. Go ahead.
The purple is steeper.
The purple is steeper by a factor of how much? Make it
Wait,
real
I can't see. 2.
close. What's the number up
3?
front? Steeper by 3.
Oh.
It grows 3 times as fast. In the world lingo, means it has a vertical stretch of 3. That's the fancy math terms. But I like steeper by 3.
Yeah.
Okay, so steeper by 3. What's another fact that you could definitely tell me from the yellow to the purple? Steeper by 3, yeah.
The purple's y is -1, and the yellow's y is 0.
Okay, so the y value on the 2 is different. The y value on the purple is -1. The y value on the yellow is 0. I like it. So our turning point is shifting. What's the last thing that we can say about this, the yellow to the purple? So it's steeper by 3. It shifted left, or excuse me, it shifted down by 1. There's one last thing we could say. I wrote it in green.
Moved left.
Yeah, the whole graph moved left 3.
2.
2. Yeah. So they're changing. All right. Let's see. This last one I have y equals -5 and then parentheses or absolute value x minus 3 and then plus 6. Is that okay? So let's put my absolute value graph up here. Okay. What will this -5 do?
Make it 5 negative. Make it. Oh, make it fatter? No.
I haven't shown you anything fatter yet.
Well, okay. Well, if positive makes it
You're
longer.
tripping. Look.
So positive,
What?
it makes it
Look at the
skinnier.
other one.
It's steeper. It's steeper and flipped. Flip
Oh, flip.
over and steeper.
I need the steeper part.
Okay, I like it.
You always said that.
I'll show you when it gets fatter in a second.
Well, because it was a negative.
That's
so I
okay.
don't know what it would do.
That's okay. No, I think it's a legitimate thing to think about. I like your.
Stay in the facts.
You're doing a great thought process. I love it.
Thank you.
That's a thought process.
Hey, what would that -3 inside the grouping do with the whole thing? Do what? Go to the right. How many? Yeah, right 3. Okay. And then what is this plus 6 going to do to the whole thing?
That's going to put 6 up.
6 up. So up 6. Move up 6. Okay. All right, so I'm not worried about the flip over yet. I'm going to go right 3. 1, 2, 3. So I'm moving that point. 1, 2, 3, and up 6. 1, 2, 3, 5, 6. So this to that is now there. Now it's going to open at a rate going down. So I'm going to go right 1 down 5. And left 1 down 5. Then I can go right 1 down 5 more. And left 1 down 5 more. So let's use some verbiage. There are actually 4 things that has happened to this graph. Let's give me the 4 major things. From the yellow to the purple, what is one thing we noticed? Yeah.
It's upside down.
It's upside down, so it flipped. Absolutely.
And it's, what's the middle point called?
The turning point.
Turning point is up.
Turning point is up. How many?
6.
6, yeah.
The purple one is steeper.
The purple one's steeper by a factor of what?
I really don't feel like doing math.
What's the
-5.
number out in front?
-5.
Yeah, it's steeper by 5. And what's the last thing? It flips. So we have it flips. It moved up by 6. It's steeper by 5.
I didn't hear what he said.
I'm right here.
No, not you. The weird one over there.
I'm not weird, you're weird.
You're the one with the hole in his pants.
That's because they're too small.
Get bigger pants.
No, you know I can't. They're right now.
Take off your
These are my football pants.
All right. So, since we got
Okay, that's.
Since we're talking about his church pants because they're holy.
Oh.
All right, so it flips upside down. It's steeper by a factor of 5. It moved up 6, and what's the last thing it did?
Right 3.
Right 3. So there's all kinds of things that are taking place. Agree?
Yes. See.
All right. And I have last 2, and then I have to make sure I show you one that's a fatter one. All right.
Fat.
What
Fat with a pH.
pH? So the parent function will make like this. So what will this minus 2 inside do? Right 2. What will this plus 3 outside do?
Bring it up 3.
Up 3. So let's change this. I'm going to go right 2, up 3. Agree? Does it open up or down? Up. And it's still going to graph right 1, up 1, left 1, up 1. So this one is the same fatness as the yellow one because it still graphs. It's just shifted on us. It shifted to the right 2 units and it shifted up 3 units. Yeah.
Okay, I know we kind of went over this in the beginning, but why is the yellow the same every time? Is it just
That's called the parent function. That's the most basic absolute value graph you could do. And so I'm showing you that from the yellow to the green, there was shifting right, left, up, down.
So if there's a test, you always have to draw the
You
yellow.
do not need. I'm putting it up there so you guys can see that it moved.
We don't need to know those exact points.
0, 0. I know it's tough.
Wait, but how do you know how far out it goes?
So the parent function is
Same.
at 0, 0, and it goes right 1, up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. But when there's a number out front, then that changes to right 1, up that number, right 1, up that number, right 1, up that number.
Okay.
Okay?
Okay, wait, so I'm confused for green. How am I, so it goes up, right every time?
Up, right.
So, will it always be the same with the other problems?
If you have something out in front, that's going to make it go steeper. So let's say we had a 10 outside that, it would go right 1, up 10, right 1, up 10, left 1, up 10, left 1, up 10.
Okay.
If it was a 4,000, it'd go right 1, up 4,000. Hopefully it wouldn't have something that massive. All right. So let me do the parent function. 0, 0, right 1, up 1, left 1, up 1, right 1, up 1, left 1, up 1. So again, that's my most basic absolute value function. So can somebody tell me what the turning point is just by looking at it? Let's see if we can shortcut it a little bit. So the turning point on the yellow is 0, 0. What's the turning point on this next one?
Is it still 0? Because it's just a negative.
It flips it over, but the turning point doesn't flip over. The turning point is going to be the same. So how does this one going to shift? Does it shift right or left?
1, 2, 3, 4.
Left.
Yep. Why left?
It's just a negative, so I'm just using my thought process.
Yeah. I got it. So what did this one do?
It's right 2, so that must be right 3.
Right 3. Okay, right 3 and?
Down.
How much?
Down 4.
Down 4. So right 3, 1, 2, 3, down 4. And it opens upside down. Right 1, down 1, left 1, down 1, right 1, down 1, left 1, down 1. So that blue one actually is growing at the same rate as the yellow one because it was right 1 and then down 1 versus right 1 and up 1. It flipped upside down. It shifted to the right 3. So 1, 2, 3, and down 4. And I think we have there's one little space that I want to put one last thing. Can we go okay? Y'all ready? Slow it is. All right, so this find a space. Let's do this. No, I'm going to change that. Let's change that to 2 over 5 x plus 3 minus 4. Okay? So my parent function looks like this. Is that okay? So let's find the turning point first. Ignore the fraction out front. What's my turning point of this one going to be? What does this do? -3 and -3, -4. So -3, 1, 2, 3, -4. 1, 2, 3, 4. It's right there. Is that okay? It's going to open up. It's going to open up. You okay with that? Now see if you can catch the pattern I'm going to do. So before, I was just going right 1 up, whatever that number was. But I'm not going to go right 1 and up 2/5. That's goofy. Watch this. Ready? Ready? I'm going to go right 5, up 2. Left 5. That's over there. That's off the screen. You see how I made it fat? So if you have a fraction out front, and that fraction is between 0 and 1, so half or a third or 3/4, you go with your bottom first. That'll tell you how far right, left to go, and that'll tell you how far up, down to go. Does everyone agree that from the yellow to the black, it's fatter? Anyone stuck with that? And then I think on your sheet, I told you what the homework would be, yes?
9B.
Yeah, number 9B. So 9B. And that's what, page 75, 76?
Yes.
And you do have a few minutes if you want to start it. I would say, give it a shot. Give it a shot. It's nice to see you all.
It is nice to see you too, Mr. Starr.